Hello, everyone, and welcome to the session. I believe we have already spoken about this specific project theoretically, which is mental health well-being analysis at pandemic times, right? And as part of this project, we were expected to identify the factors which help us identify the emotional difficulties among the kids as well as behavioral difficulties among the kids. And then we have gone ahead and conducted a survey. This survey was filled by a few parents of kids and also by kids. Since this is sensitive data and it is related to medical field, we have masked the data and we have discussed about the technical stack that we are going to use. We have also spoken about the architecture diagram. Today, we are going to show you hands-on. And I'm joined by a friend here who is going to walk us through the code. So welcome once again to the session. And we are going to have hands-on discussion now. We have CRISP MLQ framework, which is a very good framework in accomplishing the data-related projects end-to-end, wherein we first understand the business problem. We also understand the data. Then we pre-process the data, we prepare the data, and we then build the model on the prepared data. Once we build the model, we evaluate the model, and we also fine-tune the model. And we ensure that the model is of good quality. We'll ensure that it gives us the right accuracy and good performance. Later on, we deploy the model in production. And once you deploy the model in production, you also on an ongoing basis monitor and maintain the project. Can you move on further, please? So business understanding, we had a fair bit of understanding as part of our part one. Here, we have used PostgreSQL database. We have a lot of databases. Like we have MySQL, which is a relational database management system. And then we have PostgreSQL, which is considered to be most advanced database. It is object-based relational database management system. Now, obvious question that you might have is, hey, what do you mean by this? Okay, object-based. Obviously, people will have such questions, right? So I'll tell you one thing about object-based. Rather than getting into the finer nuances, I can upfront tell you that if you have data which has different types, for example, if you have survey questions, one question might say number of friends you have. It will just be a number. Another question might be open-ended, wherein you write the text in that. So this data will have numbers and also text in it. It will be a combination of these two. When you have that kind of data, usually people prefer OODBMS, right? Object-oriented database management system. Okay, and this data or this database can handle very large and very complex data sets, like this survey data set, wherein a few fields have numbers and a few questions are textual in format. And also, there are, of course, this is one prime thing, that when you have large data and complex data, and when you have wide variety of data to be put into a database, you usually prefer OODS. And one such database that we obviously have here as an example is our PostgreSQL. All right, there are a lot of other examples also. On one side, you have Microsoft SQL, MySQL, Oracle. All these are examples of relational database management systems. And on another side, you have Object Store. There's something called as Objectivity Database. You have something called a ZO database, so on and so forth, and Postgres is one of the most popular ones. Okay, can you just zoom a bit, my dear friend, further? Just to ensure that the code is visible. You can just zoom it, enlarge it, make your font bigger. You just on your trackpad need to do this, like this. On your trackpad, if you're able to see me, like this, and it will zoom in. Fine, otherwise also that's okay. You have anyways view on the menu. You can also use that menu option on view. Click on view and then probably you'll find something. Yeah. Do you have it? No. All right, forget about that. That's fine. So here you import the required libraries. And if you see, you are importing SQL Alchemy. All right. If you see from SQL Alchemy, you import create engine. And from the create engine, you try to access Postgres and you try to get the data. Okay. Once you get the data, in the original data set, I think I've already shown you as part of part one, the entire data set, right? In that data set, you'll have a lot of questions which are lengthy. For example, if you look at the second block, renaming the column names, the first question says, are you still going to school? And when I'm talking about something, my dear friend, I request you to hover your mouse on that. Are you still going to school is the first question. Can you just highlight that first question? Right, that's the first question. Are you still going to school? Right. And if you look at various other questions in that, you have the SQL keywords like where, is. All these are SQL keywords. Okay, if you look at question number 21, do you have somewhere at home? Where? Where is a SQL keyword? Whenever you have SQL keywords, and when you try to have those as your column names, and when you try to load it into Postgres SQL, it usually throws some error. Okay. Just to avoid that, what we are doing is we are renaming the different columns. Yeah. Can you just, this is a column 1, column 2, etc. We're just renaming that just to ensure that we do not get any errors. Once we get the data from Postgres, if you have the column names which have SQL keywords, that's the error that it throws. So we address that by renaming it as column 1, column 2, etc. Yeah. Can we move on, please? Can you move on, my dear friend? Can you move on to the next piece of code? Yep. So after renaming to column 1, column 2, etc. Oh, okay. Let me take you guys one step back. In the database itself, PostgreSQL database, since it was not allowing the data to be loaded, if the column names had SQL keywords, we had changed the column names as column 1, column 2, column 3, and then loaded that into PostgreSQL, number 1. Then when we are taking it into Python, we are getting back the original column names. So that is what we are doing. Column in the previous section, all the columns are there, right? Those columns, column 33, 34, etc. We are bringing the actual the actual column details back. Earlier, that actual column name was not getting loaded into PostgreSQL. The reason being, a few of the SQL keywords were there in the column name. So we loaded into PostgreSQL as column 1, column 2. Now we want to see what those original columns are. So we are getting the original column names back. And then in the next piece of code, which is renaming the this is how the data frame looks like, just for your example. Those are all the questions and all the responses. But all those questions, if you see the column names, are very big. So we are trying to compress that. For example, are you still going to school is the first question. Please, can you hover your mouse onto wherever I'm talking? Okay, are you still going to school is slightly lengthy. We are trying to condense that into going to school. If you see going to school, yeah. So for all the questions, that is how we are doing. Big question name, big column name is getting compressed, or we are renaming that into a smaller column name. Okay, next piece of code, please. A few of the columns were accidentally identified by Python as objects, as a character. We have converted that into integers. For example, friends, the fourth one, friends. Number of friends is integer, right? But it has considered that as an object. So we are changing it back to integer. This is called as typecasting or coercion, forcibly converting one data type to another. Because Python might not always understand the column data types correctly. You need to change the type. Yeah, next please. Okay, we also have auto exploratory data analysis. Okay, and we have Python profiling here. Python profiling will create an exploratory data analysis report, which is extremely helpful. Okay, so you will be able to generate exploratory data analysis. Okay, EDA, descriptive analytics, automatically. Yeah, so here we are doing a lot of things. We are taking care of the date and time column. Yeah, please can you scroll down? Further down. And we have also done feature engineering. If you see, okay, let it run, let it complete. After it completes, we'll do it. Okay. So do we need to wait for more time? Yeah, please show the executed file as well. Yep, absolutely, you need to show. Yep, this is a exploratory data analysis EDA. For each and every column, you get to understand, do you have any missing values? What is the missing percentage? How much amount of memory is being used? You will understand the distribution of that, right? What are the various options, or what are the various levels within each of the column that you have? All the details would be available. You can, of course, spend more time and understand better. Yeah, let's go back to the code. Yes. So you have date and time, which we have actually taken care of. And then what we are also doing is, there is something called as wake up time. Okay. When did you wake up? When did you sleep the previous day? Say you slept today, tomorrow you'll wake up. So we try to get the exact time on when you have woken up. And from the sleep time to wake up time, when I subtract the duration, I get the number of hours you have slept. That is exactly what we have got here. Number of hours that you have actually slept is captured. And then a lot of data pre-processing happened. We converted the text into lowercase. Some textual pre-processing was done. Yes, and then you'll have to move on further, please. Further, all the pre-processing steps you can just move on. But if you have duplicates, we get rid of that. And here, we have replaced the categorical data into numerical data. That means there is a question called as lonely. if you look at the first piece of code there, lonely, we are lonely can take lonely as a column or a feature or a variable. Not sure why it's not has three different levels: never, sometimes, and always. Never is replaced with 0, sometimes is replaced with 1, always is replaced with 2. In that way, wherever we had categorical data, we have replaced that categorical data into numbers. Yeah. Can you scroll down, please? Further. So there were a lot of categorical data because this is survey data, right? Obviously. And what we have also done is a very innovative thing here. Using the survey questions and using the responses that we have received, we have come up with output variable. Here there are two different data frames. One data frame had all the inputs and one output which is called as emotional difficulties, because we had to predict the emotional difficulty score. And then if you look at the next line, there is behavioral difficulties. So we have considered all the various inputs. Based on the responses to those inputs, we could calculate the behavioral difficulty score, which then became the output variable. Output variable was not given to us by the client. Neither was it directly available on the data set, on the survey responses. So using the data set, using the survey questionnaire data frame, using the responses of the questions, we could calculate the emotional difficulties and behavioral difficulty scores. And then by taking those scores, we'll get some numbers. Can you please scroll up to the previous block of code? Yes. So emotional difficulties, we could arrive at the score by looking at the responses given to other questions. There would be a question in which lonely was one option, cry was another option. Can you please keep hovering your mouse on that section? Yes. Unhappy is another option within a question. Worry was another option within a question. We have looked at all these options which lead to emotional difficulties. And in the next line, we have looked at all those options which relate to behavioral difficulties. And we added all those to get the behavioral difficulty score or emotional difficulty score. Then in the next piece of code, what we have done is we have also dropped all the irrelevant variables, all the irrelevant survey questions, which are not relevant for the predictions. We have removed those. How? Using domain knowledge. Okay, that's first. And then what we have done is the output variable we have discretized. From numbers, now we are getting categories. For example, if the emotional difficulty score is less than 10, okay, what we have done is we have termed that as expected. And emotional difficulties between 10 to 11, we have mentioned that as borderline, so on and so forth. Then we have moved ahead and dropped a few other columns. Okay. And just move on to the next piece of code. Yeah. Then we have done some visualization to understand more insights about the data that we had. Move on, please. We have done all the first moment, second moment, third moment, fourth moment, business decisions, visualizations. We have drawn a lot of meaningful insights. And then we have proceeded further with model building. When we have done model building, since there were three categories for each of the, there are two models that we built. One is output variable emotional score, and another model was to predict output variable, which was behavioral score. For both of these, we built models. And first model was multinomial logistic regression model. Can you move on, please, further? Multinomial because you have multiple categories. You can also try out ordinal because you have some order in the data. Then we tried out extra tree classifier. We tried out random forest technique, right? And we have implemented another technique called as RFE. Okay, RFE was another technique that we have used to select the most important features. RFE stands for recursive feature elimination. This is another technique which is used to actually shortlist the most important features from a big list of features that you have. Okay, yep, we will have to move on, please. And then we split the data into training and test. We tried implementing multinomial logistic regression, random forest, right, etc. And then we eventually figured out that multinomial logistic regression was giving us very good results and also explainability. When we looked at the classification report, which is nothing but your kind of confusion matrix, right, etc. And this is what we got. And then what we have done is we have saved the model. Can you please show that import pickle dump? Yep. We save the model in .pkl format, which is pickle format. Whenever you build a model, save it in some format, right? That was first model. Then random forest also was done. Can you please scroll down? And we got an accuracy of 0.98. Okay, and for random forest, we have done this. This is multi-category, right? Multi-class classification problem. We made it two-class classification problem. One versus rest is one technique using which, if you have multiple categories, you convert them into two categories. And then when we have built this and when we have looked at the various metrics, can you scroll down? We got ROC curve and the precision values, recall values, etc. We have built two different models. One was for behavioral score prediction, one was for emotional score. Until now, whatever we have discussed was for behavioral score. Now we have emotional score also. Yeah, can you scroll down, please? You should be a little fast, my dear friend. Okay, we have done feature elimination. RFE technique was employed. We split the data into training and test. We calculated the accuracy. And we looked at F1 score and all the other metrics. But ultimately, after running all these models, we figured out that the multinomial regression model, logistic regression model, was giving very good results. That is where we have stopped. And then what we have done is, we have done deployment. For our practice purpose, just to see how the results look like, we have deployed the model on Flask. Yeah, we have created Flask application. This is a piece of code that you can use to create, Python Flask application. There are a bunch of lines of code that you need to run. Everything we have given here for your kind consumption. Yeah, please scroll down. Yeah. If we run this, you'll be able to see the Flask part of it. Can you please show that? App.py is a file that you need to create first for Flask. And then you'll get a URL. Port number 5000 is what this Flask listens on. So you copy that URL, go to web browser, and you run it. So you have All this is built using Python, my dear friends. Okay, you have two models, right? Emotional difficulty and behavioral difficulty. So you select whatever you want, click on submit. You get this. You have a bunch of questions you need to answer. Based on the answers that you give, you'll be given a score, right? Behavioral score, if it's behavioral difficulty prediction model, etc. Can we randomly select a few things and click on submit? So it will just take a couple of minutes, while we select all these are all the various inputs, like in your survey question, the real-time data, then sleep time, etc., and click on predict. Of course, it can be done better. For example, enter sleep time. Is it seconds or minutes or hours or what is it, right? That probably can come up in the bracket. Then child has significant behavioral difficulties, is what the prediction says. So maybe parent or the physician has to intervene, look into these aspects, look into this child behaviors, and then try to give some intervention. Intervention is try to treat through some therapies, try to treat that child's behavior so that child becomes better. Okay. This is for your proof of concept. This is fine, Python deployment. But for real-time deployment, usually people prefer Heroku. Right? Now we will show Heroku also. Before that, can you just show PostgreSQL, how it looked like with respect to our data? This is how it is, friends. Again, these are all SQL databases at the end of the day. These are the various columns and you have all the responses. This is nothing but your survey questionnaire. How can you make use of your survey questionnaire in an effective manner to come up with your own output variable, using your data, come up with your own output variable and then do the prediction? How can you do it? That is what we have demonstrated. Can you push to Heroku? Can you move to Heroku now? And over to you, Srinivas. You can walk the team through Heroku deployment, please.
Sure, sir. Hi, friends. Is my voice audible? Yeah. So first step is just let us log into Heroku. Yes.
Heroku is opening up. Yeah.
Next we need to create one app.
So the program fee will be 29,500.
I'm using here by using Heroku CLI. So these are the commands we need to execute. So before I need to go to the command prompt. Okay, just let us go to the folder. Yes. Login Heroku. Yes. Heroku. So we need to enter any key to log in. Yes. Yes. So we have created project here. So let us execute these commands into the command prompt. So Heroku login is done. So already we are in our project. First step is git init. So one repository, initialize it. Then select this option. Yes. So we have initialized Git repository. Then go to now add this. Yes. Commit changes. Yes. Next. So we need to write main, not master. Then if we run, so deployment process started. So what are the requirements? It will install.
So that's how you actually go ahead and deploy the model in Hiroku, and Srinivas has run the code, and it's waiting for the processing to complete. Yeah.
It's done, deployed. So we can see we have created this app, right? So go to the settings. Go to the settings. Our app is child project 360. If you scroll down, yeah. Yes. So this is a URL. Fine. Like previous, we can select what difficulty you can submit, add responses. So child emotion is as expected.
Wonderful. So there is no issue with the child. That is what we can comment by looking at the final output, right? And Heroku, which was founded in 2007, is platform as a service. It's cloud-based platform as a service, and it supports a lot of programming languages like Java, Node.js, right, Python, so on and so forth. And eventually, Heroku was acquired by a company called as Salesforce that became its parent company. And when it comes to Heroku platform, you have enterprise version as well. And if you take that is a paid version of it. If you take those services, then you can also monitor your model in production, which obviously we cannot show you here because it's just a demonstration. But in real time, that is exactly what happens. And post deploying your model in production, when people start using the model, they also look at the final results. Okay, and then as need be, we retrain the model. All right. So hope you enjoyed this project implementation and the way we have innovatively looked at the structured and unstructured data of survey. By looking at the data, from the data, how we have deduced the output variable and how we have eventually come up with the emotional score as well as behavioral score. Hope you enjoyed. Thank you all so much once again. If you have any questions, do put it on the comment section. We'll be periodically monitoring those and we will respond to your questions as need be. Thank you so much. And thank you, Srinivas, for demonstrating the Hiroku deployment. Thank you all.